Our whole world runs on electricity, right? But it's this totally invisible force.
So, how do you actually control it? Well, the answer is kind of simple. You measure it.
Being able to measure it accurately is what lets us build, well, everything we rely on. All right, let's get into it. We're going to look at the rules, the tools, and the challenges.
First things first. To measure anything, we all have to be playing by the same rules.
That's where standards come in. They turn an idea like kilogram or ampere into something real. And these basic units, they're like the alphabet for the universal language of engineering. Okay, so you have primary standards. They're like the master copy, locked away in national labs. Then you have secondary standards. These are the working copies that labs and industry actually use.
Okay, so we have the rules. Now, what about the tools we use to do the measuring?
Some methods are direct, like an ammeter that just shows you the current on a dial. Take old school analog meters. They cleverly use magnetism from the current to move that little pointer.
But what if you're not measuring electricity directly? That's what transducers do. Turn motion into a signal.
And for tricky AC signals, rectifier instruments just flip them to DC so they can be measured.
But here's the thing, and this is super important. No measurement is ever 100% perfect.
You can get errors from, well, you, or from the environment, or the tool itself. Even just looking at a meter from the wrong angle can mess up the reading. That's parallax error. And get this, the very act of measuring something can actually change what you're trying to measure. So with all these challenges, how do we make that invisible force finally visible? This is where the digital oscilloscope comes in. It's an absolute game changer for engineers. Basically, it takes thousands of tiny snapshots of a signal and plots them on the screen. It does this so fast that it all just blends together into a live picture of the signal. Ultimately, measurement is the bridge between that invisible world and, well, all of our modern tech. So it makes you wonder, now that we've mastered electricity, what invisible force is next?